Hello everybody, shall we start? Alright, so welcome everybody. My name is Stefano Tempesta. I'm a Microsoft Regional Director and an MVP. I deliver training courses, webinars, specifically around the Azure cloud, artificial intelligence, blockchain. Today we focus on some cognitive services, specifically vision. Actually, a bit more specific than vision, custom vision. There is a difference. If you are familiar with the cognitive services in Azure, you know that there is a vision API for image processing. There is a voice API for voice recognition, speech synthesizer, and there are a few other ones around intelligent search, knowledge management, and so on. You may be familiar also with some machine learning way of operating. Machine learning operates with historical data that are trained to become a model, and this model represents basically the information that is the data set that is necessary for a machine learning service to make some prediction. Now, cognitive services like vision, like voice, are built on top of machine learning to make predictions specifically in their field of image processing, voice, and so on. And they use these trained models. So the Azure cognitive services have been built by Microsoft training these models using hundreds of thousands, if not even millions, of images, voice samples, documents, keywords, tags to build these historical data sets that can be used as a trained model for identifying images, voices, and so on. And they do a great job at Microsoft because the accuracy of this API is excellent. Although these models are created by Microsoft, by the engineers at Microsoft, and they are very generic, very purpose, very generic from a purpose perspective. And although they work well, they may not be specifically tailored to your application or your industry that for the solution that you're building. Hence, there is a possibility to introduce a customization, a custom model that can be trained for some specific purposes. And today we'll focus on custom vision. Custom vision is exactly the cognitive service for vision, but with your own model. So you get to train and consume the service through REST API. Now, because we are building this model, we have to supply, upload some images. I will show you that in a moment. Tag them. Then the custom vision API will do the training, and then you can consume an API for prediction. I have a very specific use case that I will show you in a moment for image processing, specifically screen condition. So you can identify a face in a picture and identify the condition in that face. I will be more detailed in a moment. And in that context, a generic trained model from the cognitive services for vision wouldn't work because it's not specialized for the specific business problem that we are trying to resolve. One step further is that custom vision can be deployed also to the edge, and hence the title of this session, to bring intelligence to the edge. What's the edge? Well, the edge is anything that is not necessarily cloud. It can be to your laptop, to an IoT device, to a mobile app where there is no internet connectivity that will allow to use the regular cognitive services, because cognitive services are a cloud based. They are offered in Azure as a REST API, but sometimes you may want to build a mobile app that doesn't have necessarily connectivity, or an IoT application that is running on a sensor, on a device that doesn't necessarily connect every time to the internet, and so on. So with custom vision, we can build models and consume APIs that are not necessarily available online all the time. You may need from time to time to be online again to retrain the model, improve the accuracy with new data set, with an updated data set, but typically you will be able to work at the edge without an internet connection. So let's carry on. And I already mentioned the cognitive services. They will let you build and deploy your image classifier, so specific the vision one. Custom vision allow you to add your own labels, so to do the training on your own data model, and these trained models can be downloaded and used offline. So that is, in summary, the three core characteristics, capabilities of custom vision. The way it works, and I will show you in the system in a moment, is that you upload the image, you tag them, and you say this image is an orange, this one is an apple, this one is a banana, and so on. So you have to tag the images, classify them. It can be a tedious job, and this is why I said Microsoft has done a great job in classifying hundreds of thousands of images for the generic Vision API. But in this case, we want to use our own images. We want to personalize the Vision API to use our own specific model. Before using, we need to train this model and then evaluate, which basically means let me test it, let's see the accuracy. Is it good enough? Do I have enough information? Do you have a high level of accuracy, in the model for the prediction that it's making? So we'll see how custom vision helps to understand all these different parameters. The website is customvision.ai. You need an Azure account to use it, and once you're in, you basically have this interface. So let me just shift to the browser, which is somewhere here, I believe. Here we go. So I am inside my custom vision.ai. I have a couple of projects here. I'll get back to the project in a moment. If I were to start a new project, just give it a name and choose whether you're doing a classification or an object detection, the type, and the domain. So the project type, whether it's a classification or an object detection, will basically tell you, hey, in a classification, I'm looking at the entire image. So what is this image about? Is an orange, is an apple, is a banana. In object detection, instead, I am identifying an object within a larger image. I have a lot of fruit, and I want to identify the apple inside that bunch of fruit. In the example that I will show you today, I'm doing skin analysis. So I want to identify some condition on a face. So I'm looking into the overall face. So it's a classification type. I'm not looking to identify a face of a person among all other faces. There will be an object detection. So I'll focus on classification. Then you choose the type of classification, whether it's a multi-label or multi-class. And you can see the comment here is pretty obvious. A multi-label, you assign multiple tags for each image, and a multi-class instead is a single tag. So you can say that orange, that image is an orange, is an apple, is a banana, single tag. Or you can say this is multiple tag, is an apple and is green. And this allows also to have a more granular level of classification because you introduce multiple tags. Obviously, the complexity, you can understand, is that multiple tags decrease the accuracy of if you don't have enough images of each specific tags. In the project that I will show you in a moment, you will see that my dataset is unbalanced on purpose, but is unbalanced. And custom vision will tell you exactly how it is unbalanced and what is the impact of this. Now, custom vision also has some predefined domains that you can use: food, landmark, retail, and this is just for tuning the API to some of the specific domains. So if you know that you're dealing with apples, oranges, bananas, obviously go for food. If you're doing an identification of landmarks, monuments inside pictures, then you go for landmarks. And if you are considering downloading these models for a mobile application, then you will choose the compact version. So the compact domains are sort of lightweight that can be exported, downloaded on your iOS or Android and installed to work completely offline. Okay, I don't need to create a new project for now because I will deal with an existing one, but I'll get back to my project in a moment. First, I want to go through the demo and then we'll show how that looks like from a backend perspective. Also, if you have any questions, don't wait at the end. Just type in the chat. I will be able to see these and answer if it's relevant to the specific slide of presentation of the moment. Otherwise, I will take a few questions at the end. Now, this is the application that I want to show you. And I want to start from showing the application itself and then going into the backend. We see these running in custom vision, and we see also this from a code perspective. It's a C# website that is calling some APIs, REST APIs, not complex at all. And the way basically it works is, let me go to the website where we have deployed a test application. So hopefully you can see this in a moment. Here we go. Okay, so you start your scan. This is running in the browser, but there is an equivalent version also for the API. And you can see in a moment, you will see me there. Hey there, that's me. And then you can take a photo, or you can upload a photo if you already have an image taken presently. So let's take a photo here. Okay, not the best face possible, so let me retake, let me pose a little bit better, put my face inside the oval, make a beautiful smile, and happy with that. So now we can analyze the image. Okay, now I have to put my hands in front and say this is not the most accurate system for men. Okay, this has been optimized for women first of all, and it's been optimized for a certain type of women, especially having a white Caucasian background. Why is that? Well, that is a business decision for positioning this product in this specific market. And it all depends on the images that have been uploaded. Obviously, the engine is the same. You want to change your model, you want to change your images, then it will change your audience. And as you can see, probably the light condition, probably my scary face, probably because, again, the model is not optimized for men. I got high intensity of acne, high intensity of pigmentation, medium intensity of under eye circles, which probably I do have. I have some crowns feet, which are not real feet, but they are just some lines next to the eyes. I have some wrinkles for sure because my age is showing there. And for all of these conditions, so the condition has been identified, the intensity has been identified, and there is also some product recommendation. Here we go. So they don't have for some reason, there is no recommendation for acne and pigmentation. So I'm a desperate case, but there are some product recommendation for under eye circles and so on. I don't want to promote this service per se. This is a commercial application, so I'm not gonna click on the recommended product because this will redirect to the website of our customer, and will show their products for in their e-commerce site. This is irrelevant from a presentation perspective, but again, this is a recommendation engine that has been built to match the conditions and the intensity identified by custom vision with a product catalog that addresses these conditions. So this is the commercial application of this app, of this API. So back here, what's the current? Here we go. What's the current performance of this application? It's okay, about 25% precision, but not great. It can be slightly better. Okay, where do these figures come from? They came from a custom vision. So let me go back to my custom vision backend and open the Skin Intelligent project and go into detail to understand how that works. All right. Okay. So in a moment, you should be able to see a lot of faces on screen. Is opening, and you don't see that yet. Hopefully, you will see that soon. Here we go. These are all the images. Well, not all, because you can see only a fraction of them. There are about 5,000 images that have been classified, probably even more than that. So you can see on the left-hand side here that they've been classified with some letter and number like A1, A2, C1, P2, P3, and there are 3,700 in A1 condition, 136 in A2 condition, and so on. So they have been tagged, so all these 5,000 plus images, according to a specific condition, A, C, P, U, W, and intensity 1, 2, 3, and so on. And this is a tedious job that you have to go through that. Sometimes you can buy already labeled models, but otherwise, in this case, we relied on Skin Expert that source images and from different models and from different people. So these are real people, and then went one by one and tagged them. Takes some time, but at the end, because this is coming from expert of the field, you expect to have a good accuracy, a good level of tagging. But this is one aspect of the engine. This is actually the manual part of it. So that you go through your model and you tag them. You have to do this because this is custom vision. This is your own model. There is no API that can figure this out. by itself. There is no machine learning that can do the magic. This is your decision on how you want to classify, to label all these images. After that, you do the training. You see the green button here on the top right, it says training. So this will do the training. So we basically learn all the different characteristics of these images according to the tags, and will give you the performance that you will see on screen now. Okay, so a precision, which is the number of the accuracy of your model. How likely is that an image that has been tagged with a specific condition and intensity is correct. The recall, which is a bit low, is 60%. So out of the tags which should be predicted correctly, what percentage did your model find correct? So 60%, and the average performance of the entire model, which is around 79-80%, which is okay, but not great. We are aiming to improve this and get at least to 90% of overall performance. And now, why is not that high yet, the way we wanted? And the reason is because our model is unbalanced. And you can see the image count here. For each tag, we have a very high precision. You see 97%, 98% of recall, 99% of performance for the A1 tag. And this is expected because we have over 3,700 images for A1. So our model is very, very strong there, it's very robust. But as soon as we go into another one here, so C3 down here, you see that we only have 500 images, not even. So the precision drops significantly. The recall is very low, and so on. So this means that we need to have a better balance in our model to improve the accuracy overall. And this recommendation is given here. You see this little triangle with an exclamation mark. That is a warning for you. It's telling you that the distribution of images for each tag is not uniform. So if you want to ensure a better model performance, you should aim for approximately the same number of images for each tag. In this way, the model can learn and improve its accuracy over time. So this is what we did at the beginning. Upload the images, tag them, train, and then we can start using the prediction through the API. You can actually do it from this UI itself, from the browser. So if you go to predictions, that's me. That's the image that we just uploaded. So here you can upload also other images and test them in real time. But obviously it's not fun because you are testing within the browser. It's not from your own app. It's much better if you do it from the app itself. And which is what we have I showed you before. And I will show you in a moment also the backend code, how easy it is to do that. Now, where is the things? I think it's here. The settings. Here we go. Yes. So in the project settings, you will be able to access the project ID, key, endpoint, and a few other things that are necessary to configure your application. So let's go to Visual Studio. Okay, I'm in Visual Studio now. Hopefully you will see in a moment. Here we go. You see Visual Studio now. I have some C# code, so hopefully you can follow this and see how easy it is. So to use this custom vision, you need a couple of NuGet packages. So let me go into NuGet here and see. These are the two packages that you need. It's a very long name. Let me wait until it comes out on screen. Here we go. So it's Microsoft.Azure.Cognitive Services.Vision.Custom Vision. Okay, so and it makes sense, right? So this is a Microsoft product, is on Azure, is part of the cognitive services, specifically the Vision API, but is a personalized vision, it's a custom vision. And we have two flavors, the prediction and the training API. The training API is for you to programmatically upload the images, tag them, and run the training. And the prediction is to consume it. So everything that we have seen that I show you here, right? Sorry, not here, but in here. So all these images that I have uploaded in the system and I tag them, they're coming up on screen now. Here we go. So all these images, I lied a little bit. Yes, you can upload the images from here, but we didn't really upload 5,000 images in the browser. We have all the images in OneDrive, and then we use the API, the training API, to upload the images, tag them from an Excel spreadsheet, and then train the model. So yes, for small projects, you can upload in the browser. You don't need to do this programmatically. But if you want to scale, if you want to go for 100 or 1,000 of images, classify so you need the two APIs. So let me go back to Visual Studio. You need the training API, which is exactly what I said, image upload, tagging, and training. And then you need the prediction API. So you need the managed package for which is a wrapper around the REST API for using this in your application. So this application basically creates a client connection initially to the training client. So you see here, I'm connecting to the training client to a specific endpoint using a specific training key. From there, I get the project Key Intelligent. You remember the project here? So this is my project, and it's called Key Intelligent. Okay, so this is the unique name of my project. So I get a list of projects, and I take the first project matching this name, which is unique anyway. Also here, instead of first, I can use a single. It will be the same. Okay. From there, I save my project ID and a specific iteration. What is this iteration and why is hard-coded? Well, the iteration is here. After I do a training, I have an iteration. And an iteration has a specific name, which is used for publishing this train model. So this is take it as the name of the train model. I can train this multiple times, and I can publish this model multiple times in multiple iterations. Every iteration has a specific name. You see, this has been published with this name. For some reason, the API doesn't have a way to retrieve the iteration by name. So I decided to hard code it. And I know that this is not the best practice, and obviously this should be in a configuration file. This is not production code anyway. But for now, let me say, get this iteration name. So it can be hard-coded, it can be in a configuration file. You cannot get it through the API at the moment anyway. But that's okay. That fits the purpose for now. I have a client connection to the training API. And with this training client, I can upload images, I can tag images, and I can train, obviously. The interesting part is the analysis, though, which is this little piece of code here. In the analysis, I just send an image. This image has been uploaded through the browser, has been saved somewhere in a temporary storage on the server. So I have a path to the image. I send this path to my analyze function. And as you can see, this is a sort of an API which is completely asynchronous. All these custom vision APIs are all asynchronous REST API. So it returns a collection of predictions. How does it do that? Well, first of all, I need to create a connection to the prediction client. So see the difference here. Before I connected to the training client to obtain a reference to my project, to my Skin Intelligent project. So this I can get it from my training client. After that, for doing the analysis, I create a connection to my prediction client. Same endpoint. The endpoint is absolutely the same, different key. Prediction key here, training key here. Okay, so there are two different keys, same endpoint, because there are two different APIs. Then create a memory stream from this image, from this file, and then call the classify image asynchronously, which is the method in my API to classify the image. And this basically wants the project ID, which is Skin Intelligent, wants the iteration name, hence the name. For some reason, it doesn't want the iteration ID, which is funny, bizarre, because if I go back in here, you see that I do have an iteration ID. Okay, it's coming on screen in a moment. I do have an iteration ID, but it's not useful, or it cannot be used in the API. The API wants the iteration name. Okay, so just a quick tip in case you get stuck using the API, passing the ID the way I did. Because if you look into that, you see it will. I don't know if you can see the pop-up here with the IntelliSense. Basically, is asking for the published name. So this has to be the iteration name, and then obviously the stream itself. The classify image async will return an image, a result, which is an image prediction. And this image prediction basically contains a collection of predictions with a tag and probability. Now, the reason that it does a collection is that a single image, so if I go back to this image here, to my image collection, a single image can have multiple conditions. So you can say that this person is A1, C2, P3. So can have different conditions. And this is why when I run my application here, my demo, I got multiple conditions: acne, pigmentation, circle, crown's feet. So the system, the app it identifies multiple conditions because the model is trained to have multiple tags. And because I have multiple tags, so going back to my code, I get multiple prediction of each tag. Not only I get the tag, so A1, A2, A3, whatever it is, I also get the probability, which is a number between 0 and 1. How likely, or probably probability is not the best name here. This is more of a accuracy. So how likely is that this tag has been identified correctly? It is a probability, yes, but it's more an indication of accuracy in this case. So in my app, I take only tags, only prediction that have a higher probability than, say, 0.9%, 0.9, which is 90%. So if the likelihood is that this tag has been identified correctly is very high, then I take this prediction in consideration. Otherwise, the result may not be extremely accurate, and I don't want to display wrong or misleading result. And again, the accuracy of the model depends on the quality of the images itself. And because this app or this project has been trained with apps or with images of white women, middle age, elderly, there are a few men, but very few. The majority is white women. Then obviously this is quite biased towards that gender and that ethnicity. And this is purely a decision from a business perspective. Also, quality of the image taken has a big influence. So you can see that here the light is not great in my room at the moment. Is 10 in the evening here. I'm basically in Australia. I'm in a room with very poor illumination on purpose. So the picture is not great. Obviously, in natural light condition with a better face than that, and being a woman middle age, it will fit the model much better and get a better prediction overall. All right, I hope this makes sense. So as I return the collection of prediction, so this will go back as an enumerable, so a collection of prediction. Then this will go to the recommendation engine, and the recommendation engine will match with some specific product, and it will say, hey, you have under eye circles, medium intensity, which is probably C2 as a tag in my Skin Intelligent project, and these are the products that you should buy to improve, ideally, hopefully, your skin condition. All right, so hopefully this makes sense for everybody. So we talk about this, we talk about the packages. So if you are a C# developer, a .NET developer, I highly recommend that you use the managed packages because they are wrapped around the API, so it will make consuming the API, the custom vision API, very simple. If you are not a C# developer, or if you are building an app in a front-end app in JavaScript or React, Angular, Vue, whatever framework you are using, you can still consume the REST API. At the end is an endpoint that accepts an input payload in JSON and return a JSON response. So you can totally do custom vision even if you're not doing C#. You can do it in JavaScript, you can do it in Python, you can do it in any programming language that support a call, an HTTP call to a REST API. Okay, easy. And we have seen this. I'll show you in the project itself. So this is the training client. So there are some APIs to create the project, create the image, create the tag, train the project, and publish the iteration. So everything that you can do through the UI, you can do it also through the API. So you don't have to access the customvision.ai website. So there is a question, where can we find the endpoint for Angular or JavaScript? It is here. So if you go there to my project here, go to this cog icon, the settings icon on the upper right corner, and you will find the endpoint here, and the key as well. Obviously, every call has to be authenticated. Where do you find the description of the JSON file? Is not in here. The description of the JSON file, the JSON to send, is in the documentation of Custom Vision. Just Google it. Just search for Custom Vision. You will go to the documentation and you have a full description of how you should structure your JSON payload and what you get in response as well. Okay, so the training API support creating a project, an image, tagging, training, and publishing the iteration. And the prediction API has the classify and the detect. So if you remember at the beginning, I mentioned classification and object detection. So you have these two APIs: how to classify an image, which returns a collection of prediction, and how to detect an image, which returns the position of an image inside the position of inside an image. And maybe we'll talk about object detection another time. So that's it, really. Vision.ai documentation. So the slide will be shared, so no worries. I think the session has been recorded as well. So you have access to this information also after this webinar. And there is a video that it is not about me, is done by Microsoft on channel 9, which you may know is a Microsoft official channel for this sort of webinar and interviews, and in general video promotion of their services. There is this video here, how to train and how to identify images using Azure Custom Vision, if you want to hear also another voice. But it's very simple. Believe me, if I can do it, you guys are much more tech than me for sure. Jump into that. I'm a C# guy typically, so I use the managed packages from NuGet. It's very simple. If you want to do React or Angular, you can do. You can call the REST API as well. Just don't forget to authenticate your API call. So you need to add the key as an authorization bearer, which is a token basically, and you're in. Easy peasy. That's all, guys. Thanks for watching. Thanks for listening.